purpose of these videos that I'm making is kind of just documenting what I learned because it makes it easier for me to, actually find the motivation to study and keep on going. Um, but yesterday, I had a thought that it was kind of funny. So basically, the relevant thing is this: human nature kind of sucks, and I guess by this point, it is just a standard. We're not going to be able to change it anytime soon. And the example that I have, the one that I want to talk about right now, is that humans will always, I guess, find a way to weaponize technology. And, you know, that's not the best thing that you could do with technology. There's other stuff that I would say are more valuable. But it happened before. It's gonna keep going on the future, and probably unless human nature changes, is never gonna stop. And the example that I'm gonna give you is yesterday I was learning about electron transfers, electrons moving around between the lattice of atoms or just on the atmosphere or the vacuum of the universe is something that's pretty relevant for us to study today because our understanding of it is not. We could understand more things, and especially me, I'm learning about this stuff right now. So yesterday I was surprised. I'm very, very happy to learn that the aurora borealis, or aurora borealis, I don't know how do you pronounce that on English perfectly, but those shining lights and like clouds that we have on the North and South Pole, those are caused because certain atoms, in this case, if I understand correctly, it's oxygen. When an oxygen atom gets hit by an electron, oxygen has a not filled outer shell of electrons. So it will take more electrons or it will lose them and just get rid of them. And that's how oxygen kind of comes in very many different forms. Specifically with the aurora borealis, I read an article. Well, it's not an article; it's a paper from a guy. But he said that the reason, certain colors were produced is because he pointed out that oxygen, depending on where the electron ends up in an orbital of the oxygen, is gonna produce a certain color. So he specifically, I'm gonna just go ahead and grab the specific, so that there's no confusion. Okay, I'm gonna have to find for the paper. I'm not gonna do that right now. I think it was a p orbital made like a red color, and a d orbital was the bluish colors, or it was not red, it was more like a green color, and then the d orbital was a blue color. But whatever, I was pleasantly surprised when I found that out. Then I proceeded to think about, if someone asked me today, or if I even asked myself, why is it relevant to like learn this type of stuff? Because it's very complex stuff. It just happens on the atmosphere. Why would that be relevant to me today? And the answer is, understanding of electrons has gotten us very far and has given us technologies that we really underappreciate today. Just to be exact, for example, on this specific case that I thought about, oh, it's so hot. On this specific case that I thought about, you know, when an electron hits the oxygen and it gets on the orbitals of the oxygen, and it transforms to an ion and whatever, the thought of that I had is this: that's basically a resistance. An electron hit the oxygen and then it stayed right there. And one very relevant thing that we study today is how electrons move around a crystal lattice of a metal, and how much resistance it has, and how much voltage do you need to actually cross the electron to, like, let's say, the other side of a p and n junction. So it is very relevant today. And I thought, that stuff about not resistive to the movement of electrons, it is something that is very important for us to get today, because that will allow us to get a superconductor. And superconductors, if you haven't heard about them, when you do, you're not gonna stop hearing about them. There are gonna be such a good technology to have once we have them. And again, how is that relevant today? I could give you an example. It would be an MRI. An MRI machine, I have no idea how it works. How do you get images from the magnetic thing? But I can tell you right now, I've heard it has helium, liquid helium as a coolant, and not like conducting magnets. It is an electrical machine. And no one would argue today that MRIs are a bad product out of human innovation. Society is better off today for having MRI machines. I don't think you could ever argue otherwise. And MRIs are a result, well, not a result, but an outcome that we had because of our understanding of superconducting materials and just magnetic fields around an electric current. And that is very good. So that's what I thought. If you ever think that it's not relevant, just think about that. And then I thought, on the bleeding edge of technology today, superconducting materials right now would make it possible to have fusion power today if we get it right. Because a tokamak reactor, it's a fusion reactor, but the most relevant and important thing today is that it is a magnetically confined fusion plasma. And for the magnetic fields to actually contain the thing, the electric currents are insane. And that's why we need superconducting materials, because just regular wires ain't gonna cut it. And on that same sense, on the same day, which was yesterday, I read about interstellar nuclear engines. And all of the interstellar nuclear engines require a superconducting material, because all the nozzles, it's a magnetic nozzle. So it's like a magnetic confinement nozzle, so that you can confine the plasma and then shoot it out the back. And I read a lot of things about these engines, like the exhaust velocity of the plasma, like the energy level of the photons, like the waste heat that they create, what kind of fuels you need to use. And I remembered all of these details, and the last thought that I had was, man, if you fired one of these engines on the atmosphere, that's basically well, not exactly, because it's not gonna look exactly the same. But I'm not kidding you. It's exactly like a laser gun from Star Wars, because it's a plasma, so it's incredibly hot. Um, it is completely like electrically produced. Like there's no propellant. Once the projectile gets out there, it's out there. It doesn't propel itself. It just moves out, and it is gonna have a glow too, and it is gonna shoot incredibly fast. So basically these interstellar engines, if you shoot them in the atmosphere, they're gonna be the closest thing that we have today. Well, not today. They don't exist yet. We haven't made one of those. But when we do, they're gonna be really like the closest things that we probably are gonna get to a Star Wars like laser gun, or not just even a Star Wars gun, I guess, but just any kind of laser gun. There's gonna be some differences. Like for example, instead of like a ball of plasma that's gonna shoot out, it is gonna be more like a beam because it moves really fast. The other thing that I guess would be kind of a little bit different would be that the damage probably is gonna be done by the gamma rays that go out and not like the hot plasma that you're shooting out, because gamma rays are gamma rays, and they're, if you're not prepared for them, they are gonna do damage. But yeah, I mean, that is what I thought of the entire day yesterday. I somehow managed to pass from learning about the beautiful green, blue colors of the auroras borealis on the poles to thinking about superconducting materials and MRIs and how relevant are those today, to then thinking transforming the future atomic nuclear engines that we're going to have on the future and shooting them on the atmosphere, because probably that's going to be the closest thing to a Star Wars laser gun that we're going to ever have. And I think that's really just human nature. Again, as I said on the beginning of the video, it's weaponizing technologies has been done before. This would not be the first time if it happens. I wouldn't even say it's been the worst one. I think there's been really bad examples of weaponizing technologies. One example would be the using of pesticides to kill people, which was done before. But yeah, I mean, it's just human nature, I guess. People are gonna dream of ways to lust for power and just taking advantage of someone else, just grabbing some piece of technology and see if you can use it to destroy something. Maybe not a human being, but to cause damage. That's what I'm trying to say. And maybe someday we will reach a point where there is some kind of institution that, or some embodiment of like human knowledge that is gonna trespass conflict and lust of power. And this is not going to happen. But for now, there is no example. And if you want to learn about superconducting materials and lasers and gamma rays and like interstellar nuclear engines, but you decide to focus more on like the Star Wars laser aspect of it, I'm not gonna judge you. Like, it's okay. If you want to learn about it, go ahead. I would argue there's like better stuff that you can learn, but it's pretty cool. I'm not gonna deny you that one. So that's pretty much it. That's what I learned yesterday, and